Hello and welcome to Mathematical Studies video. We're going to talk about normal distributions. So what are they? We have studied statistics for data sets like this one. We have a number of like a list of elements, and I calculate things like the average and the standard deviation, etc. And I've studied probability. And what do we do with this? Well, we have questions like, what is the probability of getting a 1 if I roll a dice? Now, what happens when I have a very big data set like this one? And of course I have the average and I have the standard deviation. Well, if I have a very big data set, I can calculate the probability of finding an element of that data set, a specific element of that data set. Now, when we have a population that tends to be closer to the mean, that it's more common to find somebody close to the mean, we say we have a normal distribution. And within those very big data sets, we calculate the probabilities of finding somebody within a particular range. That's what we're going to do. It's a very common situation, so it's a very typical thing to do. So here's an example we're going to be using of normal distribution, the IQ, the intelligence quotient. So in general, the average person will have an IQ of 100. That's what the average person will be. And look at this bell-shaped curve. It's bigger, it's taller when we get to 100 because that's where more people are. Okay, and as I move away from 100, there's less and less people in both directions. Now, what's going to happen is there's going to be 68% that are going to be always between 80 and 120. That's the majority of people, exactly 68%. Why do we do that? You'll know in a minute. Now, like people with an IQ less than 80 are very uncommon to find. And also people with an IQ of more than 120, those are also very uncommon to find. So this is what the normal distribution chart represents. So what do we say about this? Well, we're going to say that we have a normal distribution with a mean of 100, because that's what the average person has. And we say that the standard deviation is 20. And that's why 68% of the people fit right between 80 and 120. Realize how from 80 to 100 I have exactly 20, which is one standard deviation. This is going to be important in a minute. So this is how we normally express it. We say that x, an element x, has a normal distribution distributed normally with mean and standard deviation. And we often put the little square just to make sure we don't get confused. So again, here's my normal distribution for the IQ. 100 is the mean and 20 is the standard deviation. So the probability of finding somebody with an IQ between 120 and 130 is 0.09. We also say that if I represented the area under the curve, between the curve and the axis here, this area here, if I calculate it, would be 0.09. The area under the whole thing would be 1. And the area here from 120 to 130 is 0.09. So the probability that I find somebody, I go out on the street and I pick somebody completely random and they happen to have an IQ between 120 and 130 is 0.09. That's what the area under the curve is telling us too. So what about 70 and 80? Well, look at it. Between 70 and 80, I'm going to get exactly the same probability. Why is that? Well, because from 80 to 100 I have 20. From 100 to 120 I have 20. And they're both like 10 units wide. So since it's symmetrical, because that's important, they are symmetrical on both sides, I'm going to get exactly the same probability. And this is a property we're going to be using often. The symmetry. Very important. Let's now look back at the idea of like moving standard deviations around. How far is the value from the mean? Well, we're going to measure that in standard deviations. For example, how far is 80 from the mean? Well, 80 is going to be one standard deviation because the standard deviation is 20. So it's going to be exactly one standard deviation. And how far away is 60? Well, 60 is going to be 2 standard deviations away. And I can do that for any value. Look, for example, here, very close. I can say it's 0.15 standard deviations. Now, very important things that you must know. As I said before, 68% of the values always, for all normal distributions, not just the IQ, any normal distribution, 68% of the values are within one standard deviation, 95% within 2 standard deviations, and 99% within 3 standard deviations. And this is something they could ask you in the exam, and you should know it. So how do I calculate the probability? How do I calculate that 0.09 that I got earlier on, for example? Well, we have a population within distributed normally. Here we have my IQ population example, and I choose a random element from that distribution. I'm going to go out in the street and pick somebody completely random. So what is the probability that that person is within a range? Like, for example, between 90 and 120. Let's do this one. Well, I go to my calculator and I go to the DISTR menu, the distributions menu. You find it on top of the vars key. You have to press the blue one first. This is what you're going to see. And you will choose normal CDF. We are not going to use normal PDF. We're going to use normal CDF and env norm. So normal CDF, press enter, and you get the following screen. Just put the data in. Your lower bound is going to be 90. Your upper bound is going to be 120. Put the mean, put the standard deviation, press paste, enter again, and you get the probability. So the probability that if I pick somebody completely random in the street, their IQ is between 90 and 120 is 0.533. Rounded to 3 significant figures. And that's how it works. So, and an example of how we can apply this to like find out how many people I can find. So suppose in a town the average annual income is $20,000 and the standard deviation is 4,000. So I have my mean and I have my standard deviation. Great. And I'm going to assume it's distributed normally, although normally it's going to actually say so in the exercise. I'm going to pick 20 people at random. So how many of those can we expect to earn between $14,000 and $18,000? So I put my data in the GDC. And what do I go and get to calculate? Well, what I'm going to calculate when I put this in, I'm going to calculate, hey, I go out in the street in this town, I pick someone random. What are the chances that this person earns between $14,000 and $18,000? That's what I'm going to get here. I paste it and I get that probability, 0.242. Great. So the probability is 0.242 to 3 significant figures. So I'm going to pick 20 people. Now, if each one of them, 0.242 is the probability, how do I calculate how many of those 20 people will earn within that salary range? Well, I simply multiply. And I'm going to get 4.84. Now, this always depends how the question is formulated, but my conclusion I'm going to say now is that we can expect at least 4 people out of those 20 to be in that salary range. I could say that we can expect 5 people, because of course I'm not going to find a person that's 0.84 a person. So it's going to be 4 or 5. Depends how you can, the question is asked which one you should choose. This one perhaps is not very clear, but the whole point is that you might have to calculate the expected amount of people, and all you do is calculate the number of elements you have times the probability to find so. Thank you very much for watching. 2 more videos coming up. See you next one. Bye.